So the idea here is that we're going to talk about arc length and area of a sector. And I'm going to start by talking about area of a sector. And this was an activity that I sent out earlier this week. Hopefully you took a look at it and gave it a try. So if you haven't taken a look at it, I just want to walk you through it a little bit. Now, a sector, as you can see that I'm dragging around, this will be the area of the entire circle. And a sector is just a piece of that area, or a slice of that area, if you want to think about it like that. All right, so our goal here is that we know the whole area is 20. And so we want to drag it to create an area of 8. So our goal is to kind of give an estimate. Our estimate here is, well, let's see, 20. So we want under half of that, right? We want the area to be less than half of it. So maybe we go less than half, but not too much less. A little bit less. And let's see how close we are. Oh, not too bad. A little bit off, but not too bad. Okay, area is 7. Now the total area is 7. So we know this whole thing is 7. And we want to know where do we go to make it 2. Well, we know it's less than half. And we also know it's less than half by quite a bit. So maybe here. Oh, we're off by a little more that time. A little bit too small. Turns out that it's less than half, but 2 over 7 is also greater than a quarter. And so we know that it's some fraction of the entire area. Here's what's going to help us, is if we know the angle measure or the arc measure. Because here we go. Area is 4, and we want the area to be 3. Well, if we know the whole area is 4 and we want the area to be 3, that means we want 3/4 of the area. 3/4 of the area. So we want to go 3/4 of the way around the circle. How far is that? Well, hopefully from remembering our rotations and stuff, you remember that 3/4 of the way around would go 270 degrees. So if we know the angle measure and know that we can go exactly 270 degrees, check our answer, and it turns out, yes, that is exactly 3 for our area. Area of 30, drag the point to create an area with 6. And I'll let you think about that one and see if you can come up with the answer and with the angle measure that would get you to 6. But what I want to point out is that for most of these problems, really what you're going to end up with, since the area of a circle is pi r squared, hopefully you remember that, a lot of times you're not going to end up with exact numbers. You're going to end up with things in terms of pi. So a lot more often you'll see that the area of the sector is 30 pi, and we want to create an area of 6 pi. So just to point out that we're going to talk about pi a lot in these problems. Now the arc length is going to be a similar idea. Remember that the distance all the way around a circle, if I trace all the way around the circle and say what's, if I loop a string around the whole circle and then unwind it to figure out how long that string is, that's circumference. So circumference is our distance all the way around the circle. And so similarly to what we were just talking about with areas, the length of an arc, if I just want a piece, then what I usually say is that length equals part of the circumference. Part times circumference. Okay, and to find that fraction, to find that part, the part is going to be whatever our central angle is. Here's central angles. over 360, which would be all the way around. All right, so if I wanted to find what halfway around the circle would be, then I would go, I want to go halfway around. So what's half of 360? That'd be 180. 180 over 360 would reduce to 1/2. We said 3/4 was 270 degrees. And so most of the time you're going to be given that central angle measure and have to figure out how far around the circle it is. Have to simplify the fraction. And then circumference, remember, is 2 pi times the radius. Okay, so we take that fraction and multiply it by whatever we get for the circumference, and then we can find the arc length. All right, so our formula here is the length equals the part of the circumference. So we're trying to find the length of this red arc here. That's what we're looking for, the length of this red arc. And so our length equals the part of the circumference. And so the first thing we need to do is find the part. In other words, how far around the circle are we actually going? Because we're not going all the way around. We're only going part way around. And we can figure that out by taking 60 and dividing it. That's our central angle, dividing it by 360, and which would be all the way around. And let's chop off the zeros for dividing by 10. 6 and 36 are multiplicable by 6. So that's going to be 1/6. We're going 1/6 of the way around the circle here. 1/6 of the way around our circumference. What's our circumference? Our circumference is 2 pi times our radius. What's our radius? Our radius is 8. Here's our radius. 2 pi times 8, which is 16 pi. So you'll see on these problems that you might have to work with some fractions here. Arc length equals part times circumference. So our part is 1/6 times our circumference, which is 16 pi. And that equals, well, let's see, these are both divisible by 2, so I'm going to put, this is a 3 on the bottom and an 8 on the top. And so I'm going to have an 8 on top and 3 on the bottom, pi. And a lot of times, since the pi is really on the numerator here, since pi is really on the top, you'll see a lot of math. We like to write this as 8 pi on the top and 3 on the bottom, like this. Centimeters. And again, hopefully this formula makes some intuitive sense. That if I want to find the length of part way around, then I figure out that part, how far around am I going, and take that slice of the entire circumference. And the idea I really want you to have hit home here is that length is related to circumference. And when we get to sector, that's going to be related to area. All right, our length is still part of the circumference. And our part here is, well, our central angle here is 120 degrees. So take 120, and we're going to divide it by 360. Let's see, that's going to reduce, if you simplify it down, whichever way you want to simplify it down, you can divide by 2 and divide by 3 different places. You'll see that this is 1/3. This reduces to 1/3. So we're going 1/3 of the way around the circle, and we want to know how far that is in comparison to all the way around. Well, our circumference is going to be 2 pi times the radius, which is going to be, 2 pi r. That's going to be 2 pi times our radius is 11. So that's going to equal 22 pi. So to find the arc length, we're going to go part of the circumference. So our part was 1/3 of the total circumference. Remember, that circumference would be going all the way around the circle. So 22 pi is this length. It's probably my best tracing I've done with one of those circles. All right, this entire length of the way around the circle. And what we're finding in the arc length is, what is this distance? What is this part if I only went 1/3 of the way? Well, 1/3 of the way, then we can just write it. This one can't be simplified. So we just have a 22 pi over 3. We can't cancel something on top and bottom. Centimeters. Arc length is a distance, so it's in centimeters. Now, let me do one more problem here with circumference. Sometimes on some of these problems, you're going to be asked to solve for the circumference instead. So this time what I know is my arc length. So I know my length, and I want to solve for the circumference. So I still have my same formula, which is that length equals part of the circumference, but this time I am trying to solve for the circumference. I'm trying to solve for C. So let's look at how that looks. Our length is 4.19 inches. We know the length here. To figure out our part, we're going to take our central angle, which is 40, same way we've done before. We're going to divide it by 360. And that comes out, if you simplify it out, that comes out to be 1/9. So this is 1/9 of the total circumference. So now we're going to put those numbers in. Length is 4.19 equals our part, which is 1/9 of the circumference, of the total circumference, which is what we don't know yet. That's what we're trying to solve for. And so to solve for this, we have 1/9. So I've got a 9 on the bottom. I don't want a 9 on the bottom. So I'm going to multiply by 9 on both sides to get rid of the fraction. And so our circumference is going to be just 4.19 times 9, which is 37.71. And our units are still inches. So the only difference here is that we are given the arc length and trying to solve for the circumference. So you're going to have to do a little bit of solving of the equation on that one. All right, area of a sector. I'm going to go a little bit quicker here because it's the exact same idea except with area. So area of a sector, remember the sector is this slice, the area of the slice. Sector equals part times the area. Part times the area. So the only difference is that now we're looking at area. So part is still the same thing it was before. It's the central angle divided by 360. And then our area, well, our formula for area, remember, is pi r squared. So we're just using a slightly different formula than we used before. So it is a part of the area. Still find our fraction, figure out the total area. That's going to give you the area of the sector. All right, second example first because it's a little bit simpler. Sector is still part times the area. So we find our part the exact same way we did before. We take our central angle, 120, and divide it by 360. And we've already said that that's 1/3. Our area here is going to be pi r squared. And our radius Well, our radius here is going to be 14. It's this distance right here. Pi times 14 squared. So that's going to be 196 pi. I left everything in terms of pi because that's going to make things a whole lot easier. A lot fewer decimals to deal with. Sector is going to equal. So if the whole area is 196 pi, we want to know what a third of that area is going to be. That's what we're doing. 196 pi. So that means that our sector is going to be 1/3 of that total area of 196 pi. All right, and this is not divisible by 3, so we can't really simplify it. Sometimes you will be able to simplify and you'll get no fraction at the end, but not on this one. This one, your final answer is 196 pi over 3. And then you have feet squared now. Feet squared because it's an area. Area of a sector is still an area, and so it should be in feet squared. All right, area of the sector is still part times the area. So our part here is 70 over 360. Our central angle divided by 360. 70 over 360 is 7 over 36, and I can't really simplify that anymore. So it's going to be 7 over 36. It's going to be a little bit of a messy fraction, but that's okay. Areas, pi times our radius squared. Our radius is 8 squared. 8 squared is 64 pi. So that means our area of the sector is going to equal our part times our area. So we're going 7/36 of the way around the circle. Since the total area is 64 pi, that's going to be our part, 7 over 36, times the total area will tell me how much area this red slice takes up. Now, if we look at simplifying this fraction, I can tell you that these are divisible by 4. So if I divide this by 4, I get 16. If I divide this by 4, I get 9. So that can make the numbers a little bit smaller. So on top, I have 7 times 16 times pi. And on the bottom, I just have 9. So I get 7 times 16, which is 112 pi over 9. And the units that I get will be squared since it's an area. 112 pi over 9. All right, this last problem is the same idea we looked at for arc length before, which is that this is my sector. In other words, I already know the sector, which is 35 meters squared, and I'm trying to solve for the area. The area is what I don't know. Okay, so it's turning around the formula. We're going to have to solve an equation. Our part, we still find the same way. We take our angle divided by 360. Our angle here is 40 divided by 360. And that's going to simplify, as we looked at before, to 1/9. So in our equation, we have our sector, which is 35, equals our part, which we just found was 1/9, times the area that we don't know yet. So in order to do this, all we need to do to solve the equation is we need to multiply by 9 on both sides. Get rid of the fraction, just like we did last time. So our area is going to equal 35 times 9, which is 315. And that's going to be meters squared. Again, because it's an area. So that's our total area. 315 meters squared.